Welcome to General Structures 2 and Lateral Forces, Lesson 3 quiz, question number 10. And it says, in the truss of question 9, which I have once again just left on here, what is the stress in member B? So member B is right over here. And actually I'll get rid of this other little A that I put in there. But so we're looking for what is the stress in member B. And at this point, let's say we haven't done any of this work that we did in 10. Actually, let's assume that we have. And what would be the best way to go? Well, you could continue your method of joints, and you'd probably have to come down here, and you'd have to go up, go down to C, go up to D, and then you'd be able to get it. That's one way to go about it, or you could just use method of sections and cut. And let's go ahead and do that. That will be the easiest way. And if we have time, we'll go back and do the method of sections as well. So let's start here. What do we know? We know that we have your section, which looks like something like that. I'm going to shorten it up. That was way too long. So I just go ahead and reproduce your section. And you have right there, you've got a joint, you've got this. But really that doesn't matter. All this stuff does not matter back here. All you're really looking for is that. You have this, it comes down to a point right here. Alright. Now what you can do is say, alright, what do we have? We have, well, let's continue on with our naming of these joints. So this was E. Let's get rid of E. Let's call this E right here. A, B, C, D, E, F. All right, there we go. And we'll call this G now. Which it really doesn't matter what you name them. I just like it always bothers me when I go A, B, C, D, and then E is over here, and you go F, G. That drives me nuts. So you do it every way you want. But we're going to do this method of sections, and we're going to call this FDF, A, B, C, D, E, F. Yes, that's right. And this is F, D, E, and then we have F, C, E right here. And we also know what? We have a 25 kip load external reaction. We also have this 10 kip load external force right there. And we want to figure out how can we're looking for FDF, which is right here. How can we separate that? And the answer would be sum the moments about point E. Because if you sum the moments about point E, these two are concurrent, and therefore you can cancel them out. They will equal, the moment is going to be equal to 0. So let's do that. Sum of the, I said forces, I meant sum of the moments about point E equals 0, because equilibrium. And we want to, well, we know what the distances are. So let's go ahead and do it. We have 25 kips. That's going to be inducing a positive moment because it's going to be going that way. So we're going to say 25 kips times how distance from E is going to be 2 at 12 is 24 foot. And then we're going to add, and this is going to be a negative 10 kips since it's going to induce a moment going this way, which is opposite of what we defined as a positive moment. 10 kips times what? 12 foot. And then this, once again, the FCE goes through E, so therefore it will be 0. FDE is concurrent with E, and therefore it will equal 0, so we don't have to do anything with that. Well, you could put it in here if you're more anal than I am. You could put every single external, internal reaction on there. But I know those are going to be 0, so I don't include them to keep a little bit of cleaner calcs if you can. And then we also have FDF, which is going to be making a moment right there, so it's going to be positive. FDF, FDF, and then it's at what? 12 foot. It's at 12 foot. This distance right here is 12 foot. And we want to solve for FDF. So take 25 times 24 plus a negative 10 times 12, and we end up getting 480. And that's a positive 480. So we have 0 equals 480 foot kips plus FDF 12 foot. Alright, so as you can see, it's actually going to be negative, which makes sense because the top chord, I almost said top flange, but this top chord should be in compression because it's a single span. Alright, so we want to flip this to the other side, or I guess you could flip the 480 to the other side by subtracting a negative 480, so you'd have 480, a negative 480 over here equals FDF, and I know I'm doing this, I'm doing the math here, which I usually don't do, but that's alright. I figure we have time. FDF 480 divided by 12 equals, so you're going to have a negative 40 kips, and that's going to be in compression because it's negative. Now, if that confuses you, get rid of the negative now. Once you put that C on there, you can get rid of the negative. Or you can just say, oh, that gives me negative 40, so it's 40 in compression. You don't have to put the negative on there. However you want to do it, so that you can keep it straight, you keep it straight. So that's our answer, negative 40 kips in compression. And that aligns with A is your answer. And I guess if you want to go in there, I know that last time, looking at test taking skills, I've always been decent at taking tests, even if I don't know what the heck I was going into it. I usually learn a lot on the test and actually could figure out quite a bit. In this case, I would say A would be there. You could take 5 seconds and you could go, oh, I'm going to go with A. Because, number one, you have 3 answers in compression. So you have A, B, C, and D. This is compression, this is tension, this is compression, this is compression. So what I would say, if I just had to guess, test taking skills, once again, you have no idea, you're not doing anything, you have 20 seconds left in the test, there's no way you can figure this out. What I would say is, okay, get rid of B, it's not going to be in tension. It only has one answer in tension, then that's not going to be it. And then I'd look at it and say, okay, these were both 40 kips, this was 10, and this is 20. And in my non-infinite wisdom, I would say, well, these are both 40, so let's pick that. Figuring, oh, you got it right, you might make the mistake of saying it was intention. So the test takers might have put both on there. So I would have actually came to the same conclusion in a couple seconds if I had to guess. Once again, I would not do that if you have enough time to actually do the answer. But if you're given 20 seconds and you don't get problems wrong by answering them incorrectly, you don't lose points, you just don't get them, I would do this. So, once again, another test-taking tick from me. You can agree or disagree with it, but there it is. And I'm not going to do the method of joints. It just takes a while, and you would have to do 2 more joints, which would not take forever. Let's kind of, I always say I'm not going to do something, and then I end up doing it. So that's in tension. That means this is going to be in tension. That's a zero force member. Excuse me. If you think about it, well, if this is going this way, then this means this is your X component. It's going to be in tension. That means this has to resist it, since this has no X component. So that's going to be like so, and then that's going up, so this needs to be going down. And this will be in compression as well. And what did we say this was up here? Well, let's think about it real quick. Since you have no other X, that X has to be in compression. So therefore, that's going to be going right there into the joint. Since that's going into the joint, this is going up. You're going to have to resist it by something going down. So therefore, this member is going to be in tension. If this member is in tension, and that's where you get kind of confusing, is how much. Not confusing, you'd actually have to do the work on the figured out in the method of joints, so I won't do that. I'm going to call it quits right there. I hope that was helpful, and I will see you in the next lesson.